Yes, a merry-go-round!
That felt weird. It almost felt like there was a force trying to push me off the merry-go-round.
What's actually going on is something due to centripetal acceleration. When the merry-go-round is spinning, it has a measurable velocity, which is constant. The direction of that velocity is at tangent lines to the circle. Granted that a circle has an infinite number of tangent lines, the direction of that velocity is constantly changing. Remember that acceleration is defined as a change in velocity, so not only can there be acceleration due to the change in magnitude of the velocity, but it can also occur with a change of direction in that velocity. That's one reason why direction is such an important factor in physics. Since the direction is changing, the change in velocity is always pointing to the center of a circle. An object with uniform circular motion has acceleration towards the center. Like the force you feel when you're on the merry-go-round, you can feel the bars pressing you towards the center, and at the same time you are pressing the bars in the opposite direction. Let's do some calculations. We start with Newton's equation for solving centripetal acceleration. After we measure our variables, we can easily substitute them into the equation to give us our answer.
This is for the game win. The championship. What will he do? Oh, he goes for it, but he goes for the rebound. And he makes it. And the crowd goes wild. It's crazy. It's a party.
You're not very good at this, are you?
No, I don't know. Just never got a feel for it.
I hate to say it, but it's a physics problem. You have to understand your x and y vectors. Like this, I can drop this ball from a certain height, and there will be a time frame that elapses during the fall. If I roll the ball off a flat surface at the same height, watch what happens. Same time elapsed. That's because the acceleration due to gravity is always a constant 9.8 meters per second squared at reasonable altitudes. That's your y vector. When I drop the ball, the x vector is 0 meters per second, and when the ball rolls off the surface, it's a different given value, something like 5 meters per second. You can predict how far horizontally the ball will travel before hitting the ground by simply finding the time it would take for the ball to fall at the same height, and just plug that time value into your x velocity vector to find that distance. When you're shooting a basketball, you can calculate anything you need to know to make the basket if you have some givens. You calculate at what velocity you would release the ball, like so. Put the Vy unknown into the gravity equation, set equal to 0. Put the Vx unknown times t unknown to give the horizontal distance. We can define one variable in terms of the other. With several algebraic steps and substitutions, we can tell at what velocity to throw the ball. It's simple.
Ah, I see. It's simple. Oh my goodness. My eyes are open. My world has changed. It's friggin' simple. How could I not have seen this? I'm done. Thanks for nothing.